Greetings, welcome to today's lesson on volume of cones and pyramids. Now you may notice that I already have some things left over from our last session on volume of prisms and cylinders because almost none of this is going to change. In fact, the only thing that's going to change is this down here at the bottom, and only like super slightly. So let's talk about what is a cone, what is a pyramid. Really, those are the things we got to really deal with. I'm terrible. You've seen my artistic talent at this point. But probably the easiest one to draw is the cone. So I'll draw that second. I'll start with the pyramid. And I'll start with an easy pyramid. So we get ourselves a rectangle. And something that looks like that. In fact, let's take a moment here and define what is a pyramid, what is a cone. So let's see if I can give you the right definition here. A cone and pyramid have a 2D base. And again, it doesn't have to be on the bottom. This one happens to be. I'll draw you a cone. I'll show you. We're used to ice cream cones where the base is actually on the top. And the other point, this is terrible, is a point. So where it used to be a base to a base, now it's a base to a point. That's really what I'm trying to say here. I'm not doing a very good job of it. But a base to a base becomes now a base to a point. Now, interestingly, that turns all the sides where they used to be rectangles in a prism, they actually turn into, you can kind of see this, turn into triangles. So in a prism, all the other sides are triangles. The base still can be anything you want. It could be a rectangle, it could be a triangle, it could be a trapezoid, it could be a hexagon. Even in a cone where the base is a circle, the other part of it is actually triangular. If you've ever taken the paper off, peeled the paper off of your ice cream cone at Baskin Robbins, for example, and laid it out, you'll see it's a triangle. And it'll actually make more sense because obviously at the bottom it's a point and at the top is the biggest spot. So it's got to be bigger here and smaller here. And you can just the way I move my fingers, you can see that it's going to be triangular. Okay? So when we get ourselves a drawing like this, we need to know, well, we need some measurements. So I need to know that this is, we're going to go 8 meters. This is, let's make this 10, I'll make it 10 meters, make my life easy. And then the top, so we're like a circus tent, some kind of really big pavilion tent. These are meters. Maybe this thing is, let's make it 12 meters high. Okay, so this would be something rectangular on the bottom, and then it goes up to a single point at the way top out of the camera's view. But you know what? I don't have to change any of these steps. The only thing I'm going to change is this formula, and I'll change it when I get to it. Okay? Because I'm still going to name it. Okay? Still going to name it. Well, this is a rectangular pyramid. Now, as somebody who has actually been to Egypt and seen the pyramids and touched them, they're pretty darn impressive. And they are a rectangular pyramid, by the way. So we call them pyramids, but they are specifically rectangular pyramids, meaning their base is a big rectangle. Okay? But they all go up to a point at the very, very tippy top, which you don't get to go to. But you can see it. It's amazing. Truly amazing. I'm still going to redraw the base with measurements. This might even be more important in this situation because it really pulls all the numbers that matter for the base away from the drawing. I don't have to worry. And here I do have to be careful because I can't use the 12. The 12 is something else. This one is very specific. So the height, this is an 8 meter by 10 meter rectangle. I'm going to find its area. Well, I already know that's length times width. So 10 meters times 8, oops, getting ahead of myself there. 8 meters is 80 meters squared. I haven't changed a single thing from finding the volume of a prism and cylinder to finding a cone and pyramid. Step 4, identify the height. Now this said of the prism, so I'm going to have to change it. In fact, why don't I just change it to a generic? Height of the object. So now instead of saying height of the pyramid, or height of the prism, or height of the cone, or height of the cylinder, I can just say the height of the object. And you know that if it's a prism, it means from base to base. If it's a pyramid, it means from base to the point at the top, or bottom, or at the side. The point can be anywhere. Okay, it doesn't have to be the top. I'll show you. I'll draw a cone, and like I said, like an ice cream cone, you'll see it, exactly what I mean. And again, it's this number that I didn't done anything with. Easy. Still identified. Didn't have to calculate. Didn't have to do any math. Just went. It's that number. Boop, done. Now, step 5, finding the volume. Well, I got to change this formula. That's it. 1/3. It's not a whole. It's not base times height. It's 1/3 of base area times height. And I'll show you why. I'll actually draw. I'll give you a showing of that as well. So I got 2 things to still show you: this, a cone and why it's 1/3. But otherwise, it's just okay. So h equals 1/3. Sorry, not h. Okay. V, volume. 1/3 of 80 meters squared times 12 meters squared, 12 meters. And because I can multiply in any order, I know 1/3 of 12 is 4. 4 times 8, 80 is 320. And we're still dealing with cubic units, because anytime we're dealing with volume, we're always dealing with cubic units. We don't care what the shape is. If it's volume, it's cubic units. If it's area, it's square units. That never changes. Doesn't matter what the shape is, we call it. And you'll actually kind of, this what I find very interesting is this whole idea of the ice cream cone. Seems like, hey, they're giving you this like 1/3 as much as they probably could have given you if they had given you a bowl, for example, or a cup. I always feel like that made me feel like, what? Why would I want an ice cream cone when I get less ice cream that way? But welcome to the wonderful world of marketing. Okay. But our steps didn't really change that much. In fact, they didn't change hardly at all. You know, how to find the area, it changes from shape to shape. That's just the reality. And the volume formula for a pyramid and a cone is 1/3 of that of a prism or cylinder. Okay. So I'm going to leave my steps there, because those are, I like them. I like anything that works every single time. And it's modular, you know, I just changed the word object. Now we can put anything in there. So let me show you why it's 1/3. And I think it's funny, it's always easier to demonstrate this with a cone. So let me do that. So if I take a cylinder, okay, we know how much that holds, base area times height. If I put a little dot right here, that's going to be my point, because a cone goes from a circle to a point, and I draw this to the corners of the circle at the bottom. Look what happens. I cut this into 1, 2, 3 pieces, and I'm only going to keep one of those pieces. I only have 1/3 as much as I would have had if I'd had a cylinder of ice cream, as opposed to a cone full of ice cream. And actually, a lot of you when you go to the market with your mom or dad or whatever, or just by yourself, just take a quick look at the ice creams and look at the way they're shaped. Okay, you'll notice most of them are actually cylinders. Most of the ice cream things are cylindrical. They're big, but they're cylindrical. I mean, I had that with a tub just the other day. And some of them are a little, like, they do this a little bit, but mostly they're still cylindrical. And you're familiar with the standard ice cream cone, okay, or snow cone. I haven't had a good snow cone in a while. It's the same thing. And this is still the base. The base is still going to be this circle, whether I draw it like this whether I draw it like this, or heck, I could draw it like it's one of those yelling horns, like on the cheerleaders use when they hold up the horn, and it's like that. I mean, it's still a cone. It doesn't matter how I do it, right? It doesn't matter how it's shaped, how it's facing, right? You drive by those orange cones on the ground, right? As soon as you pick them up, they don't stop being cones because they're the way you change the facing. They're always cones, okay? So again, these steps, these step-by-step process is going to work every single time for every cone, every pyramid, regardless of the shape of the base, okay? The only thing you're going to change is you're going to have to know all your area formulas. Is it a rectangle? Is it a triangle? Is it a trapezoid? Is it a circle? Do I know how to find the area of all those different shapes? That's the thing that really puts the challenge in for you, is knowing those formulas. And if you don't know them, I suggest you write them all down and then just keep referring back to that piece of paper. Because I find that the more you do that kind of a thing, the less you'll need to. Okay, if you constantly are looking at formulas, you'll eventually have them all memorized. I mean, why do I know the trapezoid formula? You go, well, it's because you're a math teacher. You know why? No, it has nothing to do with that. It has to do with the fact that I've said it 500 times. I've shown it to people 500 times. I mean, that's just a yes, I'm a math teacher, but I learned it by just I keep showing it to you. I keep showing it. There are still formulas I have to look up. I don't know them. Okay? Because I don't encounter them anymore, and that's fine. There's nothing wrong with having to look up a formula every now and again. Okay? But that's really the only thing that changes in this whole process. And that's why I like this as hey, I can do this over and over and over again. And the only thing that's changing is I have to, different formula, different area, different area, different area. Okay? One more thing I think I'd like to throw in here, and I didn't mention it at the beginning, is the volume formula for a sphere. Volume of a sphere. And, a sphere would be like any ball you can imagine, a baseball, a basketball. Not a football, because it's not a ball. I mean, it's got to be roundish. I could not draw one to save my life. I've tried. I draw these weird, circle in a circle in a... Yeah, I can't even do it. I've tried tracing them. So a sphere is just any ball. I mean, you all know what a basketball looks like. A sphere. And the volume of a sphere is 4/3 pi times the radius cubed. And it's just a weird formula. And will you need it much in life? Probably not. If you work for a sporting good company and you're packaging tennis balls and basketballs and you're trying to figure out how to do them efficiently, then yeah, you probably will. That's probably going to be 1 in 1,000 of you at the most. Maybe more like 100,000 of you. But that's a formula that I think you're going to be asked to do on some of your homework assignments based on what I've seen. And it's just a good one. And you'll notice the R is cubed. It's again reminding us that volume is always in cubic units, and no matter what the shape is. So here it is, a round object, and we refer to it as cubic, cube-shaped units. And that's just the way it is. Okay? So this works for every cylinder. Sorry. With this formula, it works for every pyramid and cone. If we took off the 1/3 and left it as just base area times height, it would be cylinders and prisms. And that really takes us to the end of this whole year for the most part. All right, and I look forward to seeing you at some point.